So we're here to talk through this Araf puzzle by Prasanna. We've done videos for a lot of the earlier puzzles this week, so we're just going to jump right in and assume you know some basic Araf strategies. A thing that comes up is you sort of first look at any Araf puzzles to understand just some of the shape and geometry constraints of the grid and also the clue constraints of the grid. This obviously has a small clue cluster and a large clue cluster. That's the theme of the puzzle, but there are some things that you can pull out as you look closer to it. A lot of 4, 5, 6s, where a case that these 5 clues can't be near any of the adjoining clues. They could join to 1s and 2s and to the large ones about. And even in this shape, there are instances like this 1 is forced to take a small clue. This 12 is forced to take a large clue because there just aren't ways out. And the thing I notice is this 4 is particularly limited right at the start. It doesn't want to connect to these numbers nearby, which are 1 away, or the same number too far away. 4 to 6 is too far away. 4 to 1 is even too far away. And so one of the first things I see in the puzzle is that I can mark this connection coming to the right. And in doing so, I now see that I've also isolated in this corner of the grid this 5 clue. And so with 2 clues isolated inside this space, they must connect to something. I see no other small digit this 5 can connect to except for the one right above it. So we've got the start of some connections there. This 5 can't do any connections to other numbers in this space. It's too large to this, so it also has to escape out to the right. And so we have the start of the shape of some logic in this corner. And I want to quickly come to this corner and think about some of the same things. There was really one escape path out from the quadrant on these edges, and so what I see is a similar kind of situation where if I look at these 2 clues, the 14 and 15, they both don't exit this region. So, 15 right here, it doesn't have any option. It could connect to the 12 and the 14 gets out, or the 15 gets out and then this 14 connects to something, either the 14 or to the 16 or the 14 to the 12, something like that. But there's a space where there's one of these coming like this and the other one sort of coming out is a constraint that I'm seeing as real. And the others we talked about, this 12 has to connect to somewhere, and it can connect to any of these large numbers, but it has to connect those numbers. I'm even seeing that there are, There are 12 cells, including this clue here, and then that means it can almost take that corner and grab just one remaining cell and be okay. So, not too much more to make of it yet, but I think this constraint of one coming out and the other coming in will be big. And so with that as a starting point, as I'm trying to think through the next step in this puzzle, I think it's going to have to come to these 2 clues and seeing how they match up to other clues on this side. In Araf puzzles in general, when you make a connection, it's got to be very efficient, particularly along the borders. And so one first place to start is just if I did follow the border path, which would be required if this 4 connected that 14, how many cells is that? This is 9, 10, 14 total. This 4 can't connect to this 14. The next thing we can think about is connecting it to the 16. And if it connects to the 16, we're now in a situation like this. We have a 14 that is isolated and must join to one of these inner clues. Its only option is this 12. And now when these connect, we have 2 clues that need escape and 1 escape path for them. And so this 4 and the 16 don't connect. And so this 4 connects to some other clue, but it connects at least up to here and goes to a 15 or to something else in the middle. And this 5 also has to come up sort of to here and go one of these ways. And the thing that I see in making these lines is that this 4 actually can't go any farther left than this 15 because this 5 has to come up and out too. And so this has a fair amount to isolate the grid. And what it does force is once one of these connections is made, sort of put the pen in here, this 16, this 14, and this 12 now have to themselves be joined by large number to large number. There are no paths for these 3 clues to get out, and that's even a strong reason to say this 4 connects exactly to this 15, which I think we can do at this point because we can't have too many when we need to have one of these also coming in. We essentially have 1, 2, 3, and a fourth of these as clues that join, and the rest come out. And what we had discussed before is that this 14 is tricky to join to things. It can join to the 12 or the 16, but what it means is the 16 and 12 themselves don't join. And so that actually forces, if you think about the requirements, if this came up into this, it's going to strand this 12 on its own. The 16 and the 14 must be partners, is the tricky deduction that you can make at this stage of the grid. But it's thinking from the counterfactual of if the 16 were not a partner, there's no other way to join the remaining clues together that still fulfills this right side of the grid having large partners and not having essentially isolated a cell or isolated an exit path. We'll now mark in, recognizing this 12 is going to connect to one of these two things, we'll now mark in the escape path of the other clue, and all of these larger numbers are going to themselves escape out a bit. So we're going to have a set of numbers that are coming out and not touching. Recognizing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, there are 3 more cells for this to take. This 16 and 14 are going to be pretty cramped to take the space, and this 12 and something else will be pretty cramped to take the space. We talked before about how there are exactly 12 cells in this corner. One more will make 13, and so that will be the forced way that this connection happens, given that every other escape is now being used. And so we can only take at most one of the cells left, and that's the cell that the clue is in. So this 14, 16, which has to become a total size of 15, is now fairly constrained, and it's constrained because of these two boundaries, these clues with these lines that are kind of in the grid limited. We have to take many cells as we can, and they're going to be efficiently taken, so there's no way like we leave this untaken and some other cell takes it. And what I see I can't do is take this cell here, and so the most I can take by moving everything over are effectively the 15 cells I have left here that are on this edge of this margin. And there's a reason I drew my kind of sketch line sort of along the boundary, because often in an Araf puzzle you'll move left or right or up or down where you push along a boundary, but in practice the most constrained space I have is where I was drawing my boundary, and so this is 15 large. Moving all my prior notes over to the left, I can draw in these connections. And this is also similar to what you might see in a number link puzzle. I can draw these connections, but I've effectively was constrained where I didn't have a lot of choices except for those. Having these marked in, I now see this 4 is isolated in the side of the grid. It only has the option of connecting to the 6, and it has to do that efficiently with this shape. These clues now have to themselves start to get out. What we see is that having marked these in, we've isolated this group. This 5 and this 15 come together, but they need to take at least one more cell, so let's mark that in. This 5's over here, this 5, this 15, these things continue. They need to still find partners, so these all keep extending, they keep extending. This now did find a partner and is isolated, so these groups are complete. Now we have to fill some remaining space here, and we have to establish which thing connects over here. And this first part is going to just be, I guess, trivial by uniqueness. It's going to be this 14 comes into this group and is exactly 13 cells, but the way to count it is right now we've taken 6, 7, 8, 9, 10, 11, 12, 13. This will be a 14 cell region to get to this one, and this is a 13 cell region. This 1, 5 is going to take 2 more cells. At most, it's a total of 4. This region right now is 12. It's going to take 2 more cells from here. So we got +2, +2. None of those can reach to this corner cell, so this corner has to be part of this shape. So we'll mark that in as a start. See that we're at 12 here, and this also takes 2 more. So we have 6. Actually, I have something off in my count. This can only take 1 more. We've got 5 cells to take and 5 extra capacity across these regions. If we took this cell here with reach into the top, there's no way to reach this one, so this is very much forced. This can't reach all the way to here, and if this takes this cell, we can't get over to that, and so we form this 2 by 2 square, these regions around it, and we've effectively finished this puzzle. It's really looked at connecting a set of global and local constraints all together. The small numbers mostly need to connect to the big numbers, but we've got some clues like these in the middle of these things that have to connect large to large or small to small. We saw as this forced R to extend that it couldn't join to these clues, and so in connecting to some set of these clues, we were really isolating other big numbers on the side that had to connect. And I think the big breakthrough is seeing that this 16, this 14, this 12, and one other number have to form 2 large regions on the side, and that eventually forces 12 of something up top, 14 with 16 here, and then this flow in the middle to make these connections, which then has a simpler set of just long paths that eventually coalesce to get to the end. So hope you enjoyed this walkthrough of this challenging Araf puzzle, and we'll see you again soon.